In the last lecture, we have to discuss about what is the introduction of connections. After that, we will discuss up to there are two types of connections. First one, connection based on rigidity, and on connection based on rigidity, there are three types of connections are there. First one is rigid connection, second one is semi-rigid connection, and third one is flexible connections. Okay. After that, in the second type of connections, you all know that the load transfer from secondary beam to main beam and main beam to column. Okay. So whenever the load transfer from secondary beam to main beam, there is beam to beam connections in steel structure, and whenever the load transfer from main beam to column, there is a junction. There is a junction between uh, main beam and columns. Okay, so in second type of connections, there is two types of connections are there. First one is beam to beam connection, and second one is beam to column connections. Okay, so all these things will be discussed in our last lecture. Now we are moving further that there are how the load transfer from secondary beam to main beam if a main beam is connected with only one secondary beam, and in second type of example we have to discuss that our main beam is connected with two secondary beams are there. Okay, so let us moving further to our example number one, which is beam to beam connections. Okay, so the question is design a suitable web plate connections. It means we have to use web plate connections are there. So this is the figure of web plate connections between main beam. So what is the component? So this is the section of main beam which is ISWB 500 at 95.2 kg per meter. It means our main beam section ISWB 500 having a self weight of 95.2 kg per meter, and secondary beam ISWB 400 at 66.7 kg per meter connected on one side of the wave of the main beam. So as discussed earlier in the question, our figure will be like this. This is our ISWB 500 and this is our ISWB 400. Now this secondary beam is connected to the wave portion. So you can see that one side of the wave of the main beam. It means this is our main beam and secondary beam is connected on one side of the wave of main beam. Okay. Now how much load is transferred from secondary beam to main beam? So you can see that our secondary beam has to transmit an end reaction of 200 kilonewton due to factor load. It means our 200 kilonewton load is our factor load which is transferred from secondary beam to main beam. Use 8.8 grade of bolt of 20 diameter and steel grade of 410 megapascal. Now you all know that there is two types of grade of bolt are there. First one is 4.6 grade of bolt and second one is 8.8 grade of bolt. Now what is the difference between 4.6 and 8? So in 4.6 grade of bolt, its value of Fu ultimate stress is 400, and for 8.8 grade of bolt the value of Fu is 800. Okay, and you can see that it is clearly given in the question that we have to use 20 diameter of bolt and steel grade of 410 megapascal, and this grade will never be changed most of time. Okay, so let us start our examples solution. So first of all we have to find out the property of our sections. So you can see that this is main beam and this is secondary beam, and both the beams connected with the help of wave portion only. Okay, so that's why we have to use for ISWB 500, which is our main beam. So for main beam, what is this thickness? This thickness is called as thickness of web, and it is 9.9 mm. And second is secondary beam. So this is your secondary beam, and secondary beam's thickness is 8.6 mm. Now, first of all, we have to calculate for secondary beam. So, this connection, so similar connection is remain on this side. Okay, one wave plate angle is connected on this side, and another plate angle is connected on this side. Say for example, this is wave. Then one wave plate is connected like this, and another wave plate is connected like this. Okay, so on the secondary beam, both the sides wave plate is connected. Okay, so it means your secondary beam is in double shear because from both the sides a wave plate is connected. So first of all, this is the revision of your elementary structural design in which shear capacity of bolt. So the shear capacity of bolt equation is given on page number 75 of IS 800 2007, in which the equation is VDB is equal to FU by root 3 NN plus NS divided by gamma M0. Now, what is Fu? So, the value of Fu is already discussed that it is 800, because in the question it is clearly mentioned that we have to use 8.8 grade of bolt. So, the value of Fu is 800, root 3 is constant, NN. NN means number of shear plane. Okay, it is in single shear or it is in double shear, but you can see that we have to find out first of all for single shear. So the value of NN is 1, A and B. Now A and B, the equation of A and B is 0.78 pi by 4 d square. So the value of D means diameter of bolt, it is 20 mm. So 0.78 into pi by 4 into 20 square. So we will get our answer 245. What is NS? NS means number of shear plane without a shear. So there is no any shear plane without shear. So the value of NS will be 0. So this term will be 0. Now gamma MB. Gamma MB means partial safety factor for bolt, and it is 1.25. This value will be given on IS 800 2007 page number 30. Okay. So students, after calculating all these things, our answer of VDB is 90.52 kilonewton. Now this is our shear capacity of bolt. Now second is bearing capacity of bolt. So you all the students are moved to page number 75 on the right hand side. The equation of the bearing capacity of bolt will be given like this: 2.5 kb dtfu by gamma m0. Now 2.5 is constant, but the change is in the value of kb. Now in the last to last semester, you have to find out four values. Okay, from four values, the smaller value of kb will be your final value of kb. But in this semester, you have to assume that your value of kb is equal to 1. Okay, now d means diameter of bolt, it is 20 mm. T means at which portion your bolted connection has to be occurred. So it is on web portion, so we have to use TW. So for secondary beam, our value of TW is 8.6 mm, so it is 8.6. And FU, so this is a difference between, this is FU means ultimate stress of bolt, and this is ultimate stress of plate. You can see that in just below of this equation, the description of Fu will be given as ultimate stress of 0.10 megapascal. So after putting all this value, our answer will be 141.040 kilonewton. Okay, now you can see that your secondary beam is in single shear or double shear. Obviously it is in double shear because it is already discussed that one wave plate angle is connected over here and another is connected over here. It means your secondary beam is in double shear, so we have to multiply this value with the help of 2. So our double shear bearing capacity is 181.04 kilonewton. Now we have two answers. First is 181.04 and another is 141.04. But you all know that the smaller value of the bearing capacity and shear capacity will be considered as our bolt value. So our bolt value is 141.04 kilonewton. It means if we are providing one bolt, it restrained 141.04 kilonewton force. Okay, so the number of bolt required is 200 divided by 141.04. So our answer is 1.44, sorry, 1.41. It means we have to provided two bolts on the both the side of secondary beams. Okay, now you all know that pitch. Pitch means center to center distance between two bolts is called as pitch. So the equation of pitch will be given on page number 73. Okay, on page number 73 at the right hand side corner just above the table, it is given as minimum spacing. So the minimum spacing is written as 2.5 times the diameter of fastener. So it is 2.5 into 20. So our answer will 50 mm. Okay, and second is minimum edge distance. So students, the criteria of minimum edge distance will be given on page number 74. Okay, so you all the students are moved to 74 and you can see that on left hand side, second last paragraph, it is clearly mentioned that it is 1.7 into diameter of hole for hole. Okay, for manual. Okay, there are two types of there, machine flame cut and hand flame cut, but we have to design it for hand flame cut only. So 1.7 into 22, so we will get our answer 37.4. So therefore we have to provide it minimum edge distance is 40 mm. Okay, so this is the end of our secondary beam. Now the turn for main beam. So for main beam, one cleat angle is connected over here and second cleat angle is connected over here. It means one cleat angle is connected over here and second cleat angle will be connected over here. But this is a single plane. Okay, so for main beam, number of shear plane is 1. So its value is 90.52. Okay, for it is shear capacity of bolt. Now for bearing capacity of bolt, it is 2.5 into kb into dtfu by gamma mb. Now 2.5 is constant, kb is assumed as 1, d is 20 mm, t t means tw, so you can see that it is 9.9. Fu is 410 divided by 2 1.1 1.25. So our answer is 162.36 kilonewton. Okay, so this is our bearing capacity of bolt and this is our shear capacity of bolt. Now what is the smaller value? Smaller value for main beam is 90.52. So therefore our bolt value is 90.52 kilonewton. Now from secondary beam, 200 kilonewton load transferred to the main beam. So on the main beam, how many bolts are provided? So it is 200 point, divided by 90.52, so it is 2.21 numbers. But you can see that our answer is 4 because 2 volt is provided over here and another 2 volts is provided over here. Okay, so students, this is our end of our example number 1. But the question is, what is this length? This length is called as wave cleat angles length. So you can see that in this figure we have to provide it 2 bolts, 1 bolt over here and second bolt over here. Now the distance between 2 bolt is 50 mm because it is pitch distance. Now this distance is called as end distance. So this end distance is 40 plus 50 plus 40. So the total length of cleat angle is 130 mm. Now it is assumed that we have to use 90 cross 90 cross 10 mm, but it is not compulsory to you all that you have to use 90 cross 90 cross 10 only. You can also choose 75 cross 75 cross 12, 80 cross 80 cross 10, but in this example we have to use 90 cross 90 cross 10 mm, in which 130 mm long on each side of the wave of secondary beam as a wave cleat angles. Okay, so students, this is our end of our example number. Okay, so now we are moving further to our second example, which is when our one main beam is connected with the two secondary beams. So students, all the calculations are remain same. So let us discuss some fastly. So the question is, design a suitable voltage wave connection between main beam. So what is the dimension of main beam? It is ISMB 600 and two secondary beams. First secondary beam is ISMB 400 which transfer 300 kilonewton on one side of a wave of main beam. It means this is our main beam. On the right hand side, one secondary beam is connected which transfer 300 kilonewton to the main beam, and on the left side another secondary beam which is ISMB 300 which transfer end reaction of 150 kilonewton, okay, due to factor load. So it means this is our main beam. This beam transfer 300 kilonewton and this beam transfer 150 kilonewton. It means our main beam takes total 300 plus 150 which is equal to 450 kilonewton. Okay, so all the calculations are remain same. Use 8.8 grade volt and use Fe410 megapascal. Okay, so first of all, the property of given section is for ISMB 600, our thickness of wave is 12 mm. For ISMB 400, the thickness of wave is 8.9 mm. For ISMB 300, our thickness of wave is 7.5 mm. So students, first of all, we have to calculate for secondary beam. So our first secondary beam which is connected on right side, it is ISMB 400 which transfer 300 kilonewton load. So our right hand side of beam is in double shear. Okay, so all the calculations remain same as in single shear. The value is 90.52. So the value in double shear is 181.04 kilonewton and it is the shear capacity of bolt. Now the term is for bearing capacity of bolt. So for the bearing capacity of bolt, the VDP, okay, it is 2.5 into KB dt Fu by gamma m0, in which 2.5 is constant, 1 which is our KB, d it means the diameter of bolt which is 20 mm, t means thickness of ISMB 400, Fu means 410 divided by gamma mb which is 1.25. So students, Our bearing capacity of bolt is 145.96 kilonewton. Now, this is our bearing capacity of bolt and this is our shear capacity of bolt. It means our smaller value is considered as our bolt value. So, this is our bolt value. Now, how much load is transferred from secondary beam to main beam? It is 300. So, for 300 kilonewton, we have to require 2.05 bolt. It means we have to provide it three number of bolts are there. Okay, so this calculation is remain same. Now similar calculation for left hand side of secondary beam, and you all know that your left hand side of secondary beam is also in double shear because one wave cleat angle is connected over this side and another is on this side. So the shear capacity of bolt is in double shear and it is 181.04. Now the term for bearing capacity of bolt. So the equation of bearing capacity of bolt is 2.5 into Kb into D into Tfu by gamma mb. So 2.5 is constant. Our Kb is assumed as 1. D means diameter of bolt, it is 20. T. T means thickness of wave for another secondary beam, it is 7.5 and Fu is 410. So after calculating all this value, our answer is 123. Now we have two answers, 123 and 181. But you all know that our smaller value is considered as our bolt value. It means our bolt value is 123 kilonewton. Now, how much load is transferred from another secondary beam? It is 150 kilonewton. Okay, so for 150 kilonewton, we have to require 1.22 bolts. It means we have to use two bolts on left side of secondary beam. Now, the term for main beam. So you can see that this is main beam and main beam is like this. This is 3D figure. Okay. This is your right hand side of in which we have to provide it 3 bolt. This is your left hand side of bolt which is required 2 bolts. Okay. Now your main beam is in double shear because one bolting is connected over here and second bolted connection is connected over here. Okay, it means your main beam is also in double shear. So that's why your shear capacity of bolt is 181.04. Now the term is for bearing capacity. So for bearing capacity of bolt, the equation remains same. It is 2.5 kb into d into tw into fu by gamma mb. So students, after putting all this value, our answer is 196.80 kilonewton. It means if we are putting one bolt, it takes 196.80 kilonewton. But you all know that bolt value means smaller value. So the smaller value of these two value is 181.04 kilonewton. And as discussed earlier, if this is our main beam and these two are our secondary beam, this beam is transferred to 150 load and this beam transferred to 300 load. Then our main beam takes total 450 load. That's why our total reaction is 450 kilonewton. Now, if we are providing 1 volt, it takes 181.04 kilonewton. Then for 2 volt, it is 362.08 kilonewton. Now, 450 is total load coming from the both the secondary beam and 362.08 is provided if we have to provide it 2 volts. Then how much load is remaining? So it is 87.92 kilonewton. Now if we are providing 20 diameters bolt in single shear, it takes 90.52 kilonewton. Okay, so our final answer is we have to provide it 20 diameters of 2 bolt in double shear and 20 diameter provided in single shear in one side, and in one side it is for 300 kilonewton side. So you can see that we have to provided three bolts, 1 2 and 3 over here, and two bolts over here. Okay, so students, this is the end of our today's session as well as our today's lecture. Okay, so students, this is our 95 to 93 percentage syllabus cover. Okay, now in the next lecture we have to complete it our full syllabus. Okay, so this is the end of our today's session. Thank you.